sometimes you got to do a reset. So if you didn't take the quiz or the test, make sure you take it soon and enjoy your weekend. I got a warm-up problem right here for you because I love math. Math is my favorite. So warm it up, Chris. About to warm it up, Chris. That's what we're going to do. A little scalar multiplication from Wednesday. So what do I do on this one? Kind of just like distribute the 4 into all the parts of the matrices, into all the elements of the matrix. So it's going to kind of like, it's going to gotta go in here, and it's got to go in there, and it's got to go in here, and it's got to go in there, and then we write it the same way. And then, so 4 times 5 is 20. And 4 times 8 is 32. And 4 times negative 3 is negative 12. And 4 times 35 is 140. Isn't it? 77. And then you put brackets. Or you could put the big old set of parentheses, because those, remember, are the same thing as the brackets. Found that out the other day. Okay. And then that's it. Scalar multiplication. Kind of like it's just an over and multiplied. Okay? Love it. Love it. Today, what we're going to do is we're going to multiply matrices. Okay? Now, this is going to be different than scalar multiplication. I wish it were as easy as scalar multiplication, because then we could really enjoy our weekend at a lot faster time. Okay? But it's not. Okay? So this, you don't have to necessarily write down this example. I just kind of wanted to show you what we're actually doing. Okay? Here. So the rule is this. Everything in matrices, we learned this the other day, you probably didn't even know you learned this the other day. The rule in matrices is always rows by columns. Rows by columns. Okay? So when we're getting the size of the matrix, it's always rows first, columns second. When we're multiplying matrices, it's rows of the first one times columns of the second. It always follows that rule, rows by columns. Okay? Which is kind of cool because it's one rule that you gotta learn for all of the matrices. Okay? Right? So let's get it into play here. Let's dive in. So the first thing that we gotta do is the first thing I should tell you is that when we're multiplying numbers, we can multiply any number times any other number. 5 times 7, negative 6 times 8, 1/2 times the square root of 8,433. And we can multiply all of those together, and they all work. All get the downfall with matrices, matrix multiplication. Not every matrix can be multiplied by another matrix. There's one ginormous rule that you've got to follow right off the start, or the first step, I should say, not necessarily a rule, but the first step is you got to line up the sizes of the matrices. Okay, and order, because of this step, the order that you multiply matrices in matters. It's the only time in math where the order of multiplication matters. Okay? Normally, 6 times 8 is the same as 8 times 6. That's the associative property. In matrices, that does not apply. So when you line up, and again, remember, it's always rows by columns. When you line up the sizes of the matrices, those two numbers right there. So the columns of your left matrix has to be equal to the rows of your right matrix. Has to. If those two are not equal, you cannot multiply your matrices, and you're done. The problem is over because it is not possible. Okay? Not every time, every set of matrices that we give you are multiplied. dimensions, so the rows of the left one and the columns of the right one, that will give you your resulting matrix dimension. Okay? Rows by columns, rows by columns. Rows of one, or column of one has to be rows of the other, and then the result is the other. Okay? So, looking at these, it says what are the dimensions of the result. Oh, we have the breaks. What are the dimensions of the result? Now, scroll down. Okay? Right? So it's asking what are the dimensions of the answer matrix for the problem below. So again, we need to look. We need to look here. Are those two numbers the same in that one? 3 is 3. So that means that I can multiply those matrices. And that means then that these two are the resulting dimensions. So this answer is going to be a 2 by 5 matrix inside. And we'll have 2 rows and 5 columns. 2 rows and 5 columns. Letter B, what is the resulting size of the matrix? Exactly. You can't do it because these two numbers are not the same. So it's not possible. Can't handle? Got a good handle on that one? Okay. Love it. So, let's do it. So let's actually go for it. I'll give you a couple of seconds here to actually write down these two matrices. Okay. So first thing you got to do is you got to make sure that it works out, that you can do it. What is the size of the left matrix? Do you agree with 2 by 3? Oh, I got 3 by 2 now. Which one? Which one? How many rows? 3, because that's horizontal, right? 3. How many columns? 2. So this is a 3 by 2. Okay. Size of the next, right? 2 by 1, right? There's 2 rows, 1 column. So the first thing that I have to do is I have to see if I can do it. Can I multiply these matrices? Yes, I can. What is the resulting dimension? 3 by 1. So this is what I do. You don't have to do this, but then what I do is I make myself a big old 3 by 1 matrix. Okay? And now I'm going to fill in those gaps. So I make myself a big old 3 by 1 matrix until I get going. Until we all got to crawl before we can run a marathon. Okay? Now, what I'm going to do is I am going to take, remember the rule, rows by column. So I'm going to take this row right there, my first row, because the address of this one is row 1, column 1. So I'm going to take the first row and I'm going to multiply it by the first column. And how I do that is I'm going to take 5 times negative 2, and I'm going to add that to 3 times 3. That's why those dimensions have to be the same, so that multiplication will always match up. Okay? The address of this next one is row 2, column 1. So I'm going to take the second row of my left matrix, and I'm going to multiply it by the first column of my second matrix. So that's going to be negative 1 times negative 2 plus 2 times 3. Third row I'm going to take the third row times the first column, and that's going to be negative 4 times negative 2 plus 0 times 3. So I've written out my math, and now I can do negative, or 5 times negative 2 is negative 10. 3 times 3 is 9. Negative 10 plus 9 is negative 1. Negative 1 times negative 2 is 2. 2 times 3 is 6. 2 plus 6 is 8. Negative 4 times negative 2 is 8. 0 times 3 is 0. 8 plus 0 is 8. So my resulting matrix, my answer, is the matrix 3 by 1 matrix, negative 1, 8, 8. Now, if we get into a situation like this one, where we've got multiple columns and multiple rows, and that, we'll do this. So I'm going to give you guys a couple of seconds here to break down these two, and then I'll show you how we treat it with more rows, more columns. Okay? So first off, can we multiply? Yep. Okay. Dimensions of the left one, dimensions of the right one, resulting dimensions 2 by 2. So I'm going to draw myself a big old 2 by 2 matrix. Okay. This is row 1, column 1. So I'm going to take row 1, column 1. 4 times 5. Negative 3 times negative 1. Everybody in agreement with it? Okay. Now, here's the kicker. I'm going to go over here, and I'm going to say this is row 1, column 2. So I'm going to take my first row here times my second column there. So then that's going to be 4 times 0 plus negative 3 times. Row 2, column 1. Row 2, column 1. 2 times 5 plus 1 times. I didn't use green. Row 2, column 2. So row 2, column 2, 2 times 0 plus 1 times. And then we just do the math. So I'm looking here at 20 plus 3 is 23. 0 plus negative 9 is negative 9. 10 plus negative 1 is positive 9. 0 plus 3 is 3. And there, ladies and gentlemen, is my 2 by 2 result. Yeah? Questions, comments, concerns, clarifications? Good. Okay, all good in the book? Word. Let's do this. You try this one now. Go for it. Doable. Multipliable? Yeah? Dimensions of the first one, Mr. Hirsch.
3 by 1.
3 by 1, I would agree with that. Dimensions of the second. 1 by 2. So what's my result then? 3 by 2. 3 by 2. Yeah. Love it. There's my 3 by 2. So I take row 1, column 1. That's 5 times 2. row 1, column 2. That's 5 times negative 4. Row 2, column 1. 6 times 2. Row 2, column 2. 6 times negative 4. Row 3, column 1. Negative 2 times 2. Row 3, column 2. Negative 2 times negative 4. That's going to give me 10, negative 20, 12, negative 24, negative 4. Agree? That's all she wrote for that one. Any questions on that one? Dimensions, left one, 2 by 2. Dimensions, right one, 3 by 2. Multipliable. Nope, not possible. In this particular order, not possible. What if we flip the order? Then it's possible. So again, the order matters. You will get 2 different answers depending upon the order in which you multiply. Okay? Now, you might also have some wonderful type problems like this, where it says, okay, so this is a 3 by 3 matrix. Do we all agree that this is a 3 by 3 matrix? This is a 3 by 1 matrix. Are those 2 matrices multipliable? Yeah, and then the result is going to be a 3 by 1 matrix. So it's doable. Okay? We want to solve for x. So in order to solve for x, okay, I'm going to need to get there. So that's a row 2, column 1. Okay. So if I take the first row times the first column, I should get this answer, correct? Yeah? Okay. Well, that would be negative 2 times 3 plus 1 times x plus 2 times 1, and that should equal negative 2. Yes? Okay. And we solve it, we got negative 6 here plus x plus 2 equals negative 2. That's x minus 4 equals negative 2. I get x is positive 2. So did you get that? Now, we can check it by doing the next row. If I multiply this row by this column, I should get that one, right? So 3 times 3 plus 2 times x plus 4 times 1 should be 17. 3 times 3 is 9. Right? 4 times 1 is 4. 2 times 2, because x is 2, is 4. Right? 9 plus 4 plus 4 is 17. Works out. Okay. You now solve these for y. Solve this matrix equation for y. So if I'm solving for y, I would take the third row. Wrong color. I would take the third row times the first column, and it would give me y. So that would be 0 times 3 plus
didn't get to would be a word